Thanks for having me today. I am the CEO of a nonprofit organization called Thorn, and I'll be presenting along with Ranju, who's the director of, different titles here, Director Artificial Intelligence at AWS. We've been working with AWS for, I think, over 5 years now on our fight to end online child sexual abuse. And before I get into talking about machine learning and AI today, I want to actually just start with the human. I think that is the most important thing that we can ever start with or talk about when we are starting to talk about AI and machine learning, and especially in the field in which I work. This is something I often say, and it's weird. I said it once, and someone said, democratize, that seems like it makes it better and easier for everyone. And when it comes to child sexual abuse has been around from the dawn of time. We make no claims that technology created it, but it definitely made it grow faster, made it accessible to anyone in the world, and we have seen the impact on children grow dramatically over the last 2 decades. So what I'm talking about there is the buying and selling of children for sex, driven by the availability of online marketplaces and the kind of anonymity that people feel when they can shop for people online versus having to go out in person. And then the second area of work that we work on that I won't talk about today is the spread of child sexual abuse material, or what is legally called child pornography. So if we think about what happened with child sexual abuse material, before the internet, it was nearly eliminated. You had the trade of images and video through the mail. The internet came, push of a button, you share an image, it goes around the world. And today, in the US alone last year, more than 45 million images and videos of child sexual abuse were reported to the National Center, and that was from only 12 tech companies. The rest of the tech companies don't look for it yet. So we are looking at massive growth rates when it comes to child sexual abuse, and not to mention the emerging trends like live streaming sex abuse, where someone who doesn't even have access to a child can pay to watch someone else abuse the child in a more impoverished nation. So our organization spent a year or more, about 10 years ago, diving into this intersection, trying to understand how has technology changed the game when it comes to child sexual abuse, and then came up with a theory of change around how do we invest in technologies to defend children from sexual abuse. It wasn't something that had been done at scale because, as you can imagine, this isn't a market that has a profit at the center. This is a market where it's really hard to attract talent because I can't pay them as much as, you don't get stock options. But what we have found is actually we can do this. And over the last 10 years, we've built an organization that looks very much like a software company. We have software at work today in 38 countries, working to stop the spread of child sexual abuse material and stop child sex trafficking. I'm going to focus today on our first area of work around child sex trafficking after having kind of laid out that whole landscape. And I want to first start with helping you understand what I mean when I say child sex trafficking. We're going to be talking today specifically about domestic minor sex trafficking, which means trafficking in the US and actually in Canada. Not global trafficking. It presents itself very differently all around the world. To do that, I want to take you in to understand exactly what this is, because I think a lot of people have different conceptions of what trafficking is in the US, and a lot of it's probably fueled by media portrayals of this that aren't always accurate. So we went out into the field. We've done this twice now, but our most recent survey was about 2 years ago, where we went out into the field. We worked with 24 survivor organizations. These are organizations that rehabilitate children who have been trafficked. And we asked them to help us administer a survey with these children in a trauma-informed way, to hear from them directly about their experiences with technology and how technology influenced their trafficking situation. So we could understand, could technology be a part of ending trafficking and ending the trauma that comes with it? 24 organizations across 21 cities, 260 survivors interviewed, predominantly were girls, but there were boys in there as well. So a split across that. To give you a sense of who these children are, or kind of the age range, the 1 in 6 had entered the life. You'll hear me call it the life. That's what often these children will call it. Entered the life before the age of 12. The most frequently reported age of entry was 15. The average was 14. And the youngest reported was actually born into a trafficking situation, which probably means their parents were traffickers and started selling them from the time they were born. So we are talking about, some people will say, well, these are teenagers. If anyone has children, you know a 12-year-old is a child, a 13, a 14, 15, 16, 17, 18. These are children. And so I want to make no mistake about what we are talking about here. And I want to remind you, this is in the United States. And so just for that clarification, when you hear trafficking, a lot of folks think, are these people brought in across borders? No, these are American children. There are people who are brought in across borders, and that is definitely a part of this. But most times than not, they are children who are born here. Consistent in almost all types of domestic minor sex trafficking is trauma prior to being trafficked. So often, a lot of times in media, you'll hear about someone being snatched off the street, right? Or like just walking down the street and they're trafficked. Absolutely can happen, but the majority of time, that's not the case. We see 71% said their father was not involved in their life. For those who lived with their mom, they still experienced abuse. Nearly 40% had experienced emotional abuse, 25% physical, and 35% had their primary caregiver, when it was their mother, be addicted to drugs or alcohol. Most of them had also, because of neglect or abuse in their lives, had also intersected with either the foster care system or with juvenile detention. So the reason I'm telling you this is because what we are dealing with and what we see presented online are highly traumatized individuals even prior to being trafficked. So that it creates a vulnerability for them being trafficked in the first place. And this is exemplified, I think, in this quote from one of the survivors. I was groomed very well at the beginning, and then my abuser switched on me in a very mean and cruel way. And at that time, I thought that I loved him. And then it came to the point where I was deathly afraid of him. So just to give you a sense of how this goes down, you have a 12-year-old who comes from an abusive home. Perhaps they've been extracted from their home and put into foster care. Or perhaps they're living on the streets because they ran away. Or perhaps they're just seeking someone who will actually take care of them because they don't have that at home. They meet someone who says, I will take care of you, I will be your boyfriend. Most likely that person is 18, 19, 20, 21 years old, and they are kind, and then they are not, and then they make that child earn money. And often when I've listened to the recordings of these interviews, it says that the child, and this was an insight we had when we started building our software, that the child told us that they often had to write their own ads online because their trafficker would be running 3 or 4 girls at the same time and say, you need to go bring back $1,000 tonight, or you'll get beaten, or you'll be put in an ice bath. So all of a sudden now, I'll show you in a minute the marketplaces where these children are sold, which are very messy from a data perspective, but you have an insight that a child may have written the ad that sold themselves. One of the insights we got is that almost 50% of the children said that the trafficker had earned their full trust within a month of meeting them. Which leads us to this fact that even today, most of the children we talked to that were recovered still did not want to prosecute their traffickers. One of the memories that's seared in my brain is in one of the first few months of my job here, about 8 years ago, I went to a juvenile detention center. This is another crazy thing that up until recently, these kids would be arrested for prostitution when they aren't even old enough to consent to sex. And I met with about 5 girls that were about 15 years old. 2 of them had been in and out of that facility 3 times already by the age of 15. Not one of them wanted to prosecute their trafficker, and most of them said that they missed their boyfriend who had sold them for sex. So if you think about kind of a Stockholm syndrome type of experience, you have a highly traumatized individual who needs protection, who finds someone who will give them that because they've never had it, and then that person exploits them for money. And then came the internet. So trafficking and prostitution has happened on the streets and in brothels for years. The internet came along, marketplaces popped up for this type of behavior. These marketplaces are not dedicated to children in the US. They are really for adults, but this is where children are sold. So there are escort sites all across the US. Every single ad says that the person is 18. It's not like you can go on and find the ad for the 13-year-old. They all say they're 18. They all give a fake name. But in there is an 11, 12, 13, 14, 15-year-old child. And the question for us was, how do we know which ad is a child if we're going to focus our energy on that? So the advent of the internet dramatically changed the game of how this exploitation happens. So back in 2004, only 38% of individuals said that they ever were advertised online, and that skyrocketed to, to about 75% now of children will disclose that they were advertised online in their trafficking situation. Also, we see that children who are advertised online are more traumatized. 50% of victims advertised online had more than 8 buyers a day. So now we know we have a highly traumatized individual writing their own ads on an online marketplace, and now we know time is of the essence, because for every day that passes, that child is being violated on average 8 times. For every single day. So that led us to the business question. How do we get to these kids faster? Time is of the essence. So we went out and we had talked to survivors. We're trying to understand, is there a technical intervention here? And then we went to look at, well, what do these online marketplaces look like? This is a screen grab of, actually this was Backpage.com. Backpage went down about 1.5 years ago when the Department of Justice or the federal government seized it for a variety of illegal activities. But this is basically what the front page of the escort section looked like on Backpage. And all of you are squinting because you can't see it, which just tells you also it's really messy. And there's a bunch of words and a bunch of emojis, not any pictures. You don't know what it is. And oh, by the way, if you're watching this on your screen, you hit refresh, it's just it's just posting new ads. And at that time, when we started about 4 years ago, we were seeing about 150,000 new escort ads posted every single day. I'll talk about this in a minute, but today, even though Backpage has gone down, we see almost double that amount being posted every single day. So now we've got an environment with a lot of data, and it's disconnected all over the country. And we're going to try to find a needle in the haystack. So 3 out of 4 victims posted online, over 150,000 escort ads every single day. And then we went out and we talked to law enforcement. And we said, how do you run these investigations? How do you don't have time to go after, you're not trying to go after every individual here. You're being tasked with finding children. And they said, what I just said, it's literally finding a needle in a haystack. We will sit in front of a computer, click on each of those links, look at the pictures, see if we think it looks like a child. Oh, by the way, if it really is a child, they might post a fake picture so that they can't be told, doesn't look like someone young. And maybe 1 out of 10 times that we call, they'll actually call us back to book an appointment, which is how they would recover that child, because they have so many calls. So then we started thinking, well, what our role can be is if we can get smart about how we look at this data, we can put in front of officers the most likely ads that will help them focus their energy and have a higher rate of probability of getting to a child. If they're going to call a phone number and try to make an appointment, try to make sure that you are calling a child and not someone who may be a consenting adult or is out of trauma's way in this. One other complication before I get into just how we're using AWS is what I talked about with Backpage going down. January of 2018, when Backpage was up, 80% of the volume, ad volume we were seeing was from one source, Backpage. It went down. I think there was an assumption that that would kind of destroy the market. What it did was just splinter the market. So then we saw dozens of new websites pop up. We did see a lot of fraudulent activity for quite a while, but now the market's coming back. And so now we have more than 10 sources that, as I said, are accounting for nearly double the amount of volume that we were seeing prior to that happening. So enter the tool that we built, a tool called Spotlight, which is a trafficking investigations tool for law enforcement in the US with the goal of, again, prioritizing cases so that they can get to these children faster. We have been working on this now for about 4.5 years. The data we're looking at is the text data from the ads, the images that are being posted, the phone numbers. All of these are clues that can help us understand the full trafficking situation of an individual in this environment. And this is actually when we first met AWS. We had a prototype, and we were looking at how quickly this volume was coming in and how quickly we were going to need to start creating profiles. And AWS is who we partnered with to spin that up, to be able to have the flexibility when we saw the data moving from one environment to another, and to rapidly process that amount of image. And now we're also seeing video come into these environments. One of the first features that we're using, or I should say new features that we're using, is detect text out of recognition. So in addition to obviously all the processing, looking at the power of recognition to help us in this environment. So one thing that happened when a lot of the traffic has moved to these new websites is that the text of the ad, where they're giving out the information that can help us tell if this may be a child, is being embedded in imagery instead of in a text string. So now we have 4 years of text data that we want to connect to where we're seeing the trend move. And we're collecting the images, but we've got to extract that data to be able to connect it. So leveraging detect text has allowed us to do that. And let me give you an example of how that could be used. So imagine you have a report of a missing child. The National Center for Missing and Exploited Children is given that child's images, phone numbers, last known email addresses, names, aliases, anything that could help you track that child down. If all or any of that data is actually in an image, embedded in an image, we're not going to be able to search it. We're not going to be able to find it. But if we can extract it, put it back into the database, and connect it with everything else we've seen there, very quickly we can get a hit. And one thing I will tell you is you would think, well, if a child goes missing and is using their phone number, they're not that smart. They actually usually the first time they're sold or second time they're sold, they're not seasoned enough. They use the phone number they had. We've had several cases where they pull their pictures off of Facebook, put them into the ads, and that stuff goes away after they've been in the life for 3 or 4 months because they throw their phone away, they get a burner phone, they have new images, and all of a sudden they're lost in the ether. But if we can use those moments in time to find them before the trauma gets too deep, we can use that information of a missing child right out of the gate. And this is one example of being able to use the service to get the information that we need. Right now, we're seeing about 5 to 10% of the ads have all of the text in an image. And so more and more we're moving to using the extraction to get that data. As far as the link between missing children, which I've talked about, again, a lot of these children who are being trafficked are not reported missing. That is one thing. Every case is different. But I have gone into schools where we have done trafficking education in sex ed classes, and afterwards a child comes up and says, I think I'm being trafficked. She didn't even put two and two together that her boyfriend, who was making her have sex for money, that was illegal and that shouldn't happen. But after hearing what trafficking is, she would understand that. So I want you to understand that not every child is locked in chains. Not every child is a missing child. A lot of these kids are going to school and being exploited by people in their lives. But on the intersection with missing children, the National Center for Missing and Exploited Children had about a little over 23,000 kids reported missing last year, and they believe 1 in 7 of them was a trafficking victim. And so, as I mentioned before, they have images of most of these kids. The saddest cases is when that child never has had a picture taken of them. But when they do have images, that is a direct link to find that child if they have used their face in their ad, right? And again, we go back to, it doesn't always happen that way, but usually in the first moment in the life that can happen. So all of this is public information. I think that's also really important to state. We are taking, every one of these missing posters is up on the National Center for Missing and Exploited Children's website, and every one of these ads is public on one of these sites. So we're matching two pieces of publicly available data to get to a child faster. We had 2 cases that happened recently where this really, the importance of this hit home. We go in and we train the Super Bowl task forces. So if you aren't familiar, Super Bowl is the largest trafficking event in the US every year. That, and along with most sporting events, if you think about that high convergence of men into one location, traffickers will bring all their girls in, they can make a lot of money. And so every Super Bowl, a trafficking task force is built with DHS, FBI, local and state and federal officers. We go in and train them on Spotlight. At the Super Bowl this year, the unit was trained. They had the images of all of the missing children. Day 1, they popped in an image, immediately got a hit. It was a missing child from Texas who had gone missing on Christmas Day, and within a week she was recovered. She'd been moved out as soon as Super Bowl was over. And if you think, why did it take so long? Again, the only way to recover these children is to get an appointment as someone who's buying them. And they have about 80 phone calls every hour once their phone number has gone online. So if you're not one of the first to call in and make an appointment, you're not going to get to them. So again, speed is of the essence when we're talking about this. Second one, just 3 weeks ago, we had an officer in Northern California who was actually at home one evening looking at her Facebook feed. She follows the National Center for Missing and Exploited Children. She saw that they had a new missing child. The poster was in the feed. She took a picture of it, sent it to her work email, went into the office, popped it into Spotlight, found 600 ads of that child. The child had been missing for quite a while, but not reported, had been sold for weeks. And again, within 2 weeks, that child was recovered and removed from trauma. So over the last 4 years, our tool has helped reduce investigative time by 65%. That's a way of talking about that with officers. How I like to talk about it, it has reduced the time and trauma for these children by 65%. That's not good enough. We should be getting much, much closer. But looking at new technologies that we can implement to do that is one way. We've been involved in over 37,000 cases. Over 9,000 children have been identified, over 10,000 traffickers. And that today is averaging about 8 children a day that we're able to recover across the US. So with that, I'll turn it over to Ranju and have him take us through more of the technical side.
Thank you, Julie. It's amazing the work Julie and her team does. we can only thank her for allowing me and the AWS team to be part of that journey. And if you think of the mission, which is using technology to save children and make society safer, we feel excited that we had stated a similar mission, not a similar mission, a mission for ourselves when we were thinking about the machine learning and the artificial intelligence product. And it was about trying to get that technology to as many developers as we can, so that this sort of innovation that has huge impact to society and social good can happen. And I think it's really fantastic, and just thanks for the opportunity to work with you, and we'll continue to do this as long as you'll allow us to do so. Let's get into how we enable this innovation, right? How do you make it easy for customers and our developers to have this sort of social impact, uses of positive social impact using AI and ML, right? And why is AWS the right place to do it? Of course, to start with, kind of the breadth and depth of compute, storage, databases, analytics that is available in AWS makes it easy to build some of these tools. As Julie started saying, that when they really look to scale, AWS was a place where they looked at. And that really started at that stack, right? About looking at the compute, storage, databases, and so on and so forth. Then when we started looking at machine learning, we realized that no one size fits all, right? Even Julie's org, they actually have different needs within machine learning, right? She talked about a couple of examples. Her team does a lot of other work that is kind of under the hood. How do we help that? How do we make it easy? If given a nonprofit org, if they have to hire expert scientists and engineers, it's just, as she said, it's impossible to hire, it's impossible to attract such talent. How can we help in that journey, right? And so that kind of brings us to this picture, if you may. The way we see the world is that we want to get machine learning and its enablement easy to any developer. And that's what we have done with Thorn, and we'll continue to do this with Thorn and other such customers who are looking for these sort of use cases. And the way we see the world is kind of this, what we call the three-layer cake, right? At the lowest layer, we have the most kind of open and wide set of frameworks that any scientist could need to use, right? Be it Caffe2, MXNet, TensorFlow, PyTorch, Chainer, you name it, is available within AWS. And you can just pick a framework of your choice or your development choice. You can start with that. We see most of the research and science entry at that stack. Where we see developers getting more engaged is the middle layer, right? That's our ML services, and the product is SageMaker. What does SageMaker allow customers like Julie and her team do is that if you need to build your own machine learning, in the traditional world, you have to set up fairly expensive infrastructure. You have to write a lot of code to manage data movement, manage training cycles, then manage model tuning, then deployment of this model, and then finally inference pipeline, right? When I started my journey in computer vision a few years ago within AWS, the first model was developed about 7 to 8 months since we started the work, because we had to pretty much build everything ground up at that point, right? That's 80% of the team's time gone in undifferentiated heavy lifting. Not the research, not the actual product, but really doing the plumbing work, which was absolutely no value to the product or the customer. So that's where SageMaker comes in. We start with, as you know, with machine learning journey, it starts with data. You need to have high quality annotated data, or what we call ground truth. You need that first. So we have actually a product called Ground Truth, which helps you get high quality annotated data set. Once you have ground truth, with literally a couple lines of code over the weekend, I was trying to do some experiment, and I'm not anymore a really good developer. I guess I never was really. But 4 lines of code, I had notebook, I had an algorithm picked up from one of the many algorithms that SageMaker provides, point to the data set that I already have, and click a button, I can start a training, right? So not a machine learning background, I'm a more traditional software developer. I know machine learning enough to be able to use that and create models and create inferences, right? And then once I create the model, it's equally easy for you to then just click another button and say, okay, I want to now create an inference where I want to see predictions happening, right? The prediction could be forecast, prediction could be stock market. I actually was building a model to find out who will win the Cricket World Cup that's going on, because I'm from India, I love cricket. It showed India is not going to win, so sadly. I think the model was inaccurate. I don't think it works. But things like that could be done very, very easily now, right? Just basic data set. I took all the public domain data of the teams and their records for those years and the victory, put them into S3, clicked a couple of buttons. I had a forecast model, and I said, okay, for this year, who's going to win? And it told me who is going to win or not going to win. So that's SageMaker. And again, making it easier for everyday developer to access some of these machine learning techniques, which otherwise was locked into these really core group of kind of science and research, enabled organizations like, Amazon as an example. Then we said, and again, if you look at the examples that Julie gave, when we started this discussion with Julie and her team, they had very well-defined, they understand this domain so well, and it's such a difficult domain, right? Imagine the work that they do, day in, day out, looking at this really difficult images and text, and then knowing what that implication of those are, and knowing that, I believe every person of Julie's team that I've met, Thorn that I've met, they're all have this single mission. They want to reduce that time. They want to have all the children safe. So how do they, without having to worry about machine learning, without having to worry about collecting data, without having to worry about annotated data, without having to worry about training, how can they just get a solution? How can they enable their developers, their customers to have access to what's inside an image? How to match faces? That's where our top layer, what we call our AI services stack, comes into play. And we have a bunch of services there. At a broad group, we have the computer vision services, where we are looking at a visual input and is able to give insight from that visual input. Analyze a visual input, which could be an image, which could be a video, which could be a document, a scanned document, and provide insight from those. We'll talk a little bit about those. We have a set of services around speech. So the ability to do speech to text or text to speech. As you could imagine a world where if some of this information comes to Julie's org through audio files, she would have the immediate capability to decode them, get the text, and again do the same sort of filtering that helps them identify these victims and save them. We have a set of language services which helps translation and then also comprehension. So if you have a translation is fairly easy, like if you get a input in one language, we can then provide the output in a language of your choice. So English to French, for example. What Comprehend allows you to do, and I love this service, it gives, given a body of text, it tells you what is the sentiment of the text. Is it neutral? Is it positive? So think of a review, think of an ad, right? Can give you some of the key topics in the text, key entities, key phrases, right? So what are the names in this particular text, right? What is the actual phone number if there's one? What is the address in this one? So it's easy to do. You don't have to build the machine learning models. You don't have to worry about data. Our team has done all that groundwork and created a simple to use API. All you do is get the text, call an API, you get the output, right? So those are language services. We have a set of other services which are also useful for other customers. We have a chatbot service called Lex. That's literally the heart of Alexa. It's the same service that powers Alexa. We have a service called Forecast, where given your business data, your data from your organization, it has simple, easy to use API that could do forecast for your business or your specific need. And then finally, personalized, it's about providing recommendation. Again, you can bring your specific business or organizational context data, fit it into the system, and have an easy API that provides you recommendation going forward. So that's kind of how we think we'll continue this journey with customers like Thorn to make it easier. Julie specifically talked about some of the capability that they're using around images, and hopefully in near future on video, because there is a larger cohort of these ads are getting tagged with videos. So I wanted to kind of zoom into that for a little bit to show you what those are and what are we doing to make it easier for Thorn to have a higher detection and save more kids. So at a very broad stroke, the common set of features within recognition, image, and video are these 5, right? The first one, it starts with object and scene detection, and actually, this is a discussion and a collaboration where we are always seeing, is there things that we could extract from the images that could give you more clue, right? Because if I took an image of this room right now from here, recognition would tell you there's an indoor, there's a meeting room, there's chair, there's people. Is that insight useful? And we keep having this discussion, and in some cases we believe it is, in others it's not. Of course, we have a set of core capabilities around face, which are face analysis. This is the technique in which, given a particular face, we are able to tell you what is a gender, what is the age range, what sort of emotions we are seeing in the face, what other attributes, like is that person wearing an eyeglass, sunglasses, if it's a male, do they have facial hair, so on and so forth. And then there is a very separable feature called face recognition. And here what we are able to do is we are able to take 2 faces and compare to see how likely they are to be similar, right? And that similarity expresses itself as a confidence score, and we could do against face comparison from 1 to 1, or face comparison against a database of face that a customer like Thorn might have created using the missing children database or faces that they're getting from NCMEC. We are also built features to make internet more safe, right? A lot of our customers came and told us that there's a large amount of content that's coming in, and it's actually growing, user-generated content, which has a lot of unsafe context in it. Content of sexual nature, of violence, of different quality. How can you help us? So we built this feature called unsafe image detection or video detection or content moderation, where we are able to look at a stream of video, or we are able to look at an image and able to tell you that whether there is content that is sexually suggestive, sexually explicit, and we are working on adding more sort of classes in that. And then finally, as Julie talked about it, the text in image. It's a very, very useful tool for customers like Thorn, where we are able to now look into an image and extract text. What's interesting is that a lot of this text, and this is where the collaboration is so powerful, when we started this journey, we were like, okay, scripted text, as you're seeing here, like the Amazon recognition image and video, if you look at the header, it's a well-scripted text. It's a very clear, digital font. Whereas if you could imagine, look at the text, it's Monday, but keep smiling. That text, it's fairly stylized. And you could imagine a lot of them write it in a orientation which goes, semicircular, in zigzag way. How do you detect these sort of text in this difficult condition? And that's the technology. That's what we built using deep learning and computer vision. So let's look at what face analysis does, right? And it's an important distinction here that face analysis is a very disparate technique that allows you to understand what the face is, right? And the best example I could give you is that if you go for a walk around your house and every day you see somebody, there's an ability for you to know what their age is or their gender is, and there's an ability for you to recognize them. And they're 2 very, very separable and very, very distinct set of features. So face analysis, all it does is this. Looks at a face and says, what is the gender, what is the age range, what is the emotion, is this person happy, is it surprised, things like that. Face recognition, on the other hand, allows you to compare a particular input face with 1 or more faces that a customer might have. The idea is to do a similarity match, right? Which means me and my brother have very similar faces, and the way it represents itself is that if you take my face when I was 8 and my brother's age when he was 12, it was probably a 30% match. Whereas now we have started, unfortunately for me, started to look more alike, and the comparison is at a 70% match, right? So that's what face recognition does. And then, of course, as I said, text and image. As you could see, a very stylized, different orientation. It's a very, very important kind of aspect of what the product does. And it's important because if you look at the text that gets embedded, right? As you imagine the examples that Julie gave, where you have emojis in them, right? They're written in different scripts. They're highly stylized. They're oriented in everything that a person can do to avoid detection happens on that space. And yet we are able to have a fairly high accuracy using our deep learning techniques. And again, here, with everything that we do with machine learning, it's important to understand there's a confidence score. And it's a very, very important distinction, right? Low confidence score typically means that the algorithm doesn't have a high conviction of the output. A higher confidence score says it's probabilistically this is probably more likely to be an outcome that you'll be happy with, right? And I think it's important to highlight that, and you know, as Thorn does, as does all customers, and as we highly recommend, the best use of this technology is to augment human intelligence, right? You take this output and let a human being verify the output. All output. It doesn't matter what the confidence threshold is. Have a human being verify the output, have the human being confirm the output before you take an action on that output. I think that's exactly the model Thorn is using, and that's a recommendation we make to all our customers as well. Finally, talk about content moderation, and we took a, you know, again, this is a very, very difficult topic because, you know, when we started this project, and the sort of content that's out in the internet, it's quite troublesome. And then how do you make it safe? How do you make internet more safe? And so we said, well, there's a couple of things we could do. We could take a very opinionated position of whether it's safe or unsafe. And it comes with a little bit of a trade-off that, well, that opinion by definition is subjective, right? What could be safe for me could be unsafe for you and vice versa. So we took a slightly different take on the product. We said, hey, as opposed to talking about safe or unsafe, why don't we analyze the content and let the customer, give customer a clear set of decision tree that they could apply to choose whether it's safe or unsafe for their contest, right? So hence we created this fairly hierarchical taxonomy, as we call it, which is if we find an image, we say there's explicit nudity because we think there is graphic male nudity in this. Now, if somebody thinks that's safe for them, well, that's their prerogative. But we are not making the judgment whether it's safe or unsafe. We are providing you the content. So a customer could choose to just use the top level, say explicit is unsafe and filter out, or could zoom in to say, depending on, again, their use case, their customer base, what they're trying to do, filter things out as the need. And the same with suggestive. And this is an area we are investing a ton to ensure that we find as much of unsafe content from the internet, help our customers find as much of unsafe content from the internet so that, you know, people have better access to safe and healthy content on the internet. Beyond these features, we'll keep adding new features, of course, to help customers like Thorn and NickMake and others, but what are we doing specific to improving these really difficult situations that Thorn has, right? These images come in blurry. Faces have all sort of weird things put on them so that it doesn't lend itself to easy detection. There's a bit of a cat and mouse game that Thorn has to play all the time. And if you talk to any of their folks, you'll be amazed the depth that they've gone in understanding. So this is some of the things we are doing. We have already done a lot of these improvements, you know, kind of improvement on accuracy so that we can detect and recognize faces with different poses, right? Because a lot of time what happens, the missing children face is a frontal pose where they have a very, you know, profile face uploaded. Can we still recognize that individual? Can we still recognize that face? That's an important thing. Lighting is another thing. The moment you have highlights, the moment you have shadows coming across, it's really becomes hard, even for human being, by the way. So how can we use machine learning to provide good recognition, or at least recognition with some confidence score so that the customer understands that, hey, there is a low likelihood that there's an exact match because, you know, we don't know what the lighting or the highlight is doing to the face. And then there's a lot of blur and occlusion. That's a great example where this person is probably in a dance floor or somewhere and the hair is moving around. If you take a picture of that, we don't want to trigger false matches using these things, right? It's very, very important to rather not match than create a false match. So that's the thing that we are investing highly on to ensure that we are aware of these situations, and when we are in doubt, ensure that we provide very clear either no match or low confidence match so that customers can then apply human judgment on top of it. A lot of work to do on the text side, because there's a lot of challenging text. You could see that these are fairly public domain, publicly available text. Just within that, if you could see all sort of different style, different font, and so can we detect all these, and that's where we are focusing on. And again, the thing that I would say is that the biggest thing with machine learning is that understanding the feature, understanding aspects like confidence threshold, understanding the need of human review before any action is taken on these decisions is a very, very critical aspect of these products. And I think what Thorn has done is a great example of the right use of this product to have a huge social impact. And I want to thank Julie for coming here and sharing time with us. Thank you.